Good evening. We are going to be working on lesson 1-4 today in Math 130. And I thought I would kind of just go over some of the prep skills so that you were prepared to work on the assignment. Much of this 1-4 is over unit exchange. And so it's important to be able to simplify fractions, multiply fractions, and so on and so forth. So simplifying fractions, Desmos will kind of do that for you so that you're not having to do as much on your own. But understanding when you're reducing a fraction of 4/6, you're really dividing the numerator and denominator by the same number. So you're reducing by a fraction of that equals 1. So here you're dividing both by 2. They're both divisible by 2. And when you do that, you reduce to a fraction of 2/3. Thus, a fraction of 30 over 12 can both be divided by a value of 6, a multiple of 6. And that 6 over 6 equals 1. And so when you divide the numerator and denominator both by 6, you reduce that 30 over 12 to 5 over 2. Which is actually also the same as 2.5. Much of what we do in 1-4 is also about multiplying fractions. When you multiply fractions, you actually just multiply the numerator. So 2 times 7 is 14, over 3 times 11 is 33. Likewise, 5 times 12 is 60, over 2 times 7 is 14. 60 over 14 can then be reduced by 30 to 30 over 7 because they both divide by 2. And you can also see that 2 goes into 12 6 times. So 5 times 6 is 30. And 1 times 7 is 7. Also, multiplying a whole number 100 times 3/5 is the same as multiplying 100 over 1 times 3/5. And then you can just multiply straight across to make 300. Over 1 times 5 is 5. 300 divided by 5 is 60. So let's jump into the lesson. An important page from the lesson here today on page 56. There are some great equivalents that you're going to need to use throughout the entire lesson, but I would kind of keep them handy, maybe with a sticky note if you can. There's some equivalents on length. 12 inches is 1 foot, 3 feet is 1 yard, 5,280 feet is equivalent to 1 mile. There's some weight, 16 ounces is 1 pound. There's a liquid volume, as 2 pints are 1 quart, 4 quarts is 1 gallon. We use it maybe if you're talking about milk or water or pop, soda. Time, we are going to do some exchanging, a lot of exchange of time. So 60 seconds in 1 minute, 60 minutes is 1 hour, 24 hours in 1 day, 7 days is equivalent to 1 week, 52 weeks is equivalent to 1 year, and 365 days is equivalent to 1 year. Then also we're going to do some equivalency within the metric system. So here is your base unit. We've got length, weight, and volume. And length is in meters, weight is grams, and volume is in liters. And when you go to the right, you are actually multiplying by a value of 10 each time. So there are 1,000 millimeters in 1 meter. And then when you go to the left, so from here, from milli, you're dividing by 10. So 1,000 divided by 10 is 100, divided by 10 is 10, divided by 10 is 1. Divided by 10 is 1/10, that's a deca. Divided by 10 is 100th. Divided by 10 is kilo, which is 1,000. So just like there's 1,000 millimeters in a liter, there's 1,000 liters in a kilogram. So they kind of show you the moving the decimal to the right. So if you go from kilograms to liters, kilometers to meters or kiloliters to liters, you're moving your decimal to the right 3 places. You can see that 1, 2, 3. So you'd be at 1. When you're moving from this unit, anything to the right, and you're moving to the left, you're also going to move your decimal to the left, that number of place values. And then we have some conversions between systems. So like centimeters is metric and it's moving to inches. So these are all the metric moving to the English. We have weight and the English moving to, the metric moving to English. Again, metric moving to English on the volume. And then we have some equivalents on temperature. So if you put in Celsius here, you're going to get out Fahrenheit. And this one, if you put in Fahrenheit, you're going to retrieve Celsius. And then this one is using a temperature measurement using kelvins, and that produces Celsius. And this one is Celsius, and then kelvins comes out. Okay, so if you turn to page 59, it says it works like magic. So we're going to do some conversions. So it's important that you read through the initial story here. We're going to do something called dimensional analysis in the process of converting units. So we're going to be unit conversion today. According to the unit equivalence table in the prep skills, which we'll use a ton in this lesson, 1 kilogram is equivalent to about 2.2 pounds. Quick, without thinking about it too deeply, if you want to convert your weight from pounds to kilograms, would you multiply or divide by 2.2? So you would divide for every 2.2 pounds, you're equal to 1 kilogram. It says not so easy, is it? Don't feel bad. It's confusing for me too. And I have all sorts of degrees and stuff. Our first goal in this lesson is to develop a systematic procedure that takes thinking and guessing out of the business of converting units. It's based on an idea that's so brilliantly simple, you should probably send us a sizable cash donation. If measurements in 2 different units represent the same actual weight, like 1 kilogram and 2.2 pounds, then a fraction formed from dividing those units is just a fancy way to say 1. In other words, 1 kilograms and 2.2 pounds are different ways to express the exact same amount. So we can write them in 2 different ways. 1 kilogram compared to 2.2 pounds is the same as 2.2 pounds compared to 1 kilogram, and they both equal 1. We call a fraction of this type a conversion factor. This next portion is hugely important in understanding unit conversions, so it deserves special emphasis. So there is a place here on page 60 that gives you some good examples. 2 different ways to write 12 inches is equivalent to 1 foot. 1 foot is equivalent to 12 inches. And then it says if we were to take the measurement we were given 204 inches by the second conversion factor we wrote, simply something interesting happens. So 204 inches. It says use one of these conversion factors to convert 204 inches, 2 feet. So 204 inches, if we multiply by 1 feet over 12 inches, we would then take that as over 1 and multiply straight across. So they explain here, and we would get 204 feet over 12 because inches over inches makes a perfect 1. So then we've got just feet, which is what we wanted. They wanted us to convert inches to feet. Just the units canceled, inches over inches. So it says now we can focus on the numbers and perform the arithmetic. The result of 204 divided by 12 is 17. Putting the pieces together, the entire calculation looks like this. 204 inches times 1 foot over 12 inches. The inches cancel. We multiply straight across. 204 divided by 12 is 17, and we have the units of feet. Now, it's your turn to give it a try. Let's return our attention to the beaker at the beginning of the lesson. It turns out that this particular beaker contains an evolutionary product, a revolutionary product. Dr. Phil's magic love potion, guaranteed to lure the affection of that special someone or your money back, minus a processing fee of just $29.95. The 450 milliliter potion in the beaker can be converted to liters if we multiply by a convenient conversion factor. Okay. So it says write two different conversion factors based on the fact that 1 liter is equivalent to 1,000 milliliters. So 1 liter is equivalent to 1,000 milliliters, or 1,000 milliliters is equivalent to 1 liter. So both of those are ways that we can write this equivalent. And we can multiply them both by 400 milliliters, 450 milliliters. And when we do that, this is the one that the milliliters over milliliters makes a 1. And we're left with liters. So when we do that, 450 milliliters over 1 times 1 liter over 1,000 milliliters leaves behind liters. It says, what are the units for the other calculation? Do they have any meanings? So if we go up to this one, this gives us 450 milliliters over 1 times 1,000 milliliters over 1 liter. So this one actually gives us 450,000 milliliters squared, because they become milliliters times milliliters over 1 liter. And this is not what we want because we didn't eliminate any units here. We still have 2 units. So this is the one that we want. And when we divide those, in number 4 is how many liters of magic potion are in the beaker. 450 liters out of 1,000, when we divide it, it's 0.45 liters. Now it says, according to our handy dandy conversion chart, 1 gallon is approximately equivalent to 3.79 liters. So these are the 2 different ways we can write that. Number 6 says, use one of 2 conversion factors to convert your answer from question 4 into gallons. So 0.45 liters over 1. If we multiply by 1 gallon over 3.79 liters, our liters cancel. You can see I scratched those out. So because we have liters over liters, so now we're left with gallons. And when we multiply straight across, we get 0.45 gallons over 3.79. And when we divide these in decimals, we get 0.12. And I am going to share with you my decimal screen. And my decimal screen says 0.45 divided by 3.79. And that comes out to be 0.118, and I rounded that to 0.12. Okay. So let's flip the page. Number 7 says, now here's one of the great things about dimensional analysis. Notice that it took us 2 steps to get from 450 milliliters to gallons. First, we converted to liters using one conversion factor, then from liters to gallons using another. If you're really clever, you can get there directly in one calculation using both the conversion factors you used in questions 4 and 6. So here's the one we used in 4, and then here's the one we used in 6. And if you use them at the same time, milliliters cancel, and then your liters cancel, and then you're left with gallons. And if you multiply straight across, using our rules of multiplication of fractions, we get 450 times 1 over 1 times 1,000 times 3.79, and you get 0.12. And I'm going to show you how you can multiply these in Desmos. So in Desmos, you can do a left parenthesis and then do 450 divided by 1 and make that a parenthesis, and then multiply that by another parenthesis of 1 divided by 1,000 for the milliliters. Arrow right and make a right parenthesis, and then a left parenthesis for the third fraction of 1 gallon divided by 3.79 liters, and a right parenthesis, and then you get the 0.4. What did I do here? Oopsie daisy. Point 0.45. Oh geez, what did I do here? Okay, let's try it again. Parentheses 450 divided by 1. And then 1 divided by 1,000. And then 1 divided by 3.79. That's what I meant to show you. So then we get 0.12 when we round it. Okay. Okay. Number 8 says, my house is just about 15 miles from the Gulf of Mexico on the Florida coast. How far is this in inches? Use 2 conversion factors in one calculation like you did in question 7. So we're starting with 15 miles. And it says, how far is this in inches? So they want 15 miles in inches. And so it's going to be 15 over 1. And then I need to go to my calculations at the beginning of the lesson. Remember on page 56, they did tell us that 1 mile is 5,280 feet and 1 foot is 12 inches. So 1 mile, if I want to cancel out miles, then I have to do miles on bottom. So 1 mile on bottom is 5,280 feet. So my miles cancel, but I still want to end up with inches and I'm at feet. But I know from my conversion chart that I'm going to research and find something with feet or foot, a single foot, and inches. So 1 foot is 12 inches. So my foot can cancel on bottom. Of course, I have to put it on bottom so that it cancels feet over feet. And 12 inches. And inches is what I wanted. So that's good. That's what I have here. So I'm going to show this on Desmos so that you can see that I'm multiplying these fractions. So on Desmos, I've got 15 over 1, and then 5,280 divided by 1. And then I've got 12 inches divided by 1. And so we end up with 950,400 inches. Excellent. Okay. It says converting units within the metric system. So when we converted 450 milliliters to liters, we used dimensional analysis, but it turns out that we could have just moved the decimal point. Okay. So when we moved this 450 milliliters to liters right here, we could have just moved the decimal point because liters, because 450 milliliters, if we started with milliliters right here, we moved to liters, we're going to move our decimal point to the 3 left. And we did. That would be 450 milliliters. And we start and we're going to go 1, 2, 3 is the same as 0.45 liters. Okay, let's look at number 9 on page 64. It says convert 0.23 liters of love potion into deciliters, and kiloliters. So right here to deciliters and kiloliters. So 0.23 liters into deciliters. So we're starting at liters and we're going to deciliters. We're starting at liters and we're going to deciliters. So it says move your decimal place to the right. So we're going to move it to the place to the right 1 time. So this is going to be 2.3 deciliters. And then we're going to start with 0.23 liters and we want to go to kiloliters. If we are at liters and we want to go to kiloliters, then we're going to move our decimal place to the left. 1, 2, 3. So 1, 2, add a 0, 3. So this should be 0.00023 kiloliters. Dr. Phil's potion also comes in a 0.75 gallon container. Convert this to cubic centimeters using equivalences in the prep skills table and dimensional analysis. Hint, you will also need to know that 1 cubic centimeter is a cc equals 1 milliliter. Okay, that's good to know. Okay, so we are starting with 0.75 gallons over 1. And I want to convert this to cubic centimeters. Which is also in nursing terms, it's called a cc. So 0.75 gallons. So I'm going to go from gallons to liters so that I can get to a metric system. So that means my 1 gallon needs to go on bottom. And that's the same as 3.79 liters. So there's my gallons canceled out. And then my liters needs to go to milliliters. Okay, so I can relate liters to milliliters. So to do that, 1 liter is the same as 1,000 milliliters. Okay, so my liters over liters cancels. So I'm at milliliters, and 1 milliliter is the same as 1 cubic centimeter. So that's good. So I should be good. So now I multiply straight across. I'm going to share my Desmo screen. And so my Desmo screen here is parentheses 0.75 divided by 1. And then 3.79 divided by 1. And then 1,000 divided by 1. And so we get I'll take it back. So 2,842.5. 2,842.5 cc's, which is the same as cubic centimeters. So it says, now, here's a key idea. Another way to write cubic centimeters is cm cubed, which I wrote up here, or cm times cm times cm, 3 of them. We can use this idea to convert units of volume. According to the table of equivalences, 1 inch is equivalent to 2.454 centimeters. What is the result of the following calculation? Pay close attention. So if we took 1,000 cubic centimeters, for instance, just an example, and multiply by 1 inch over 2.54 centimeters, 1 inch over 2.54 centimeters, 1 inch over 2.54 centimeters, well, this cm cubed means that we have to get rid of cm 3 times. So we are, because we've got cm, 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 which is pretty cool. So in Desmos, if you multiply this, I'm showing you here. We get 1,000 times, and then we've got 1 over 2.54. And then 1 over 2.54. And 1 over 2.54. And we end up with 61.02 inches cubed, because we have inches, inches, inches. So you can see that here. Inches, inches, inches. So 61.02 inches. Okay. So now it says, number 12 says, use the idea from question 11 to convert your answer from question 10 into cubic inches. So my answer from question 10 was 2,842.5 cubic centimeters over 1. And we want to convert that into cubic inches. Well, we just did that, right? We said 1 over 2.54 centimeters, 1 inch, and another 1 inch over 2.54 centimeters, and another 1 inch over 2.54 centimeters. So that means my centimeters cubed cancels with 1, 2, 3, and I have inches, 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 which is inches cubed. So the cool thing is we can go to Desmos, and instead of 1,000 here, we could just start off with our 2,842.5, because we already have the 1 over 2.54 3 times, and that gives us 173.46 inches cubed when you round appropriately. Right, 173.46 inches cubed. So based on what you just did, fill in the blank to create a shortcut to convert between cubic centimeters and cubic inches. So 1 cubic inch that means we're going to multiply times 2.54 centimeters over 1 inch, right? Because we have to cancel the inches 3 times. So we're going to flip this over. And when we do that, our inches cancel, our inches cubed, so we get inches, inches, inches cancel. And then we have cm, cm, cm. So that gives us the cubic right here between cubic centimeters. So we get centimeters cubed. And then it's just 2.54 times 2.54 times 2.54. And that gives us 16.4 cubic centimeters. Awesome. So the next little piece of today's lesson is all about a rate and a unit rate. So a rate is a ratio that compares two quantities. Examples of some rates are 75 miles per 1 hour, or 10 milligrams per 1 milliliter, or $15 for 2 tickets. So if you, this would be a good example if you went to the movie theater and you said it cost me 2 tickets, cost me $15. But if we really would look at that, like most people would, we would say, well, what does it cost for one of us just to go? And so we would divide that 15 divided by 2, and we would call that a unit rate, because then we have one denominator. If you take 15 divided by 2, so we would actually say, oh, 15 divided by 2 means that each ticket was $7.50 if you divided 15 divided by 2. So number 1 says, explain what is meant when we say a car is traveling 75 miles for 1 hour. And usually we write that as this, 75 miles per hour. So for every 1 hour driven, we can travel 75 miles. Okay, or we could say, if I wanted to drive 75 miles, it would take me 1 hour to do that. So let's look at number 2. It says the entire 450 milliliters of Dr. Fail's Love Potion that we've been talking about this lesson is supposed to be slowly dripped into a mixture over a 5-hour period. Kind of a pain, but express this quantity as a rate. So if we express it as a rate, we're going to say 450 milliliters over 5 hours, because a rate, again, is a ratio that compares two quantities. Then number 3 says, simplify the rate you wrote in question 2 so that it's a unit rate. A unit rate is when you only have one in the denominator. So to get this to a unit rate, we're going to divide 450 divided by 5, which gives us 90. And our units did not cancel, so it's still milliliters per 1 hour. Okay. Now it says, number 4 says, it might seem like it would be really complicated to convert this rate into liters per minute, but dimensional analysis will save the day. If we're going to end up with liters per minute, we'll need to get rid of milliliters here in the numerator and replace it with liters. And we'll need to get rid of the denominator and hours and replace it with minutes. This can be accomplished in one calculation if we multiply by 2 different conversion factors that eliminate the unwanted units, just like we did in the class portion. Do that now. Focus on putting the units you want to eliminate on the opposite side of the fraction when writing your conversion factors. Write your answer in decimal and centimeter notation. Okay, so we're starting with 90 milliliters per 1 hour. And they wanted us to switch that to liters per minute. Okay. So I have to exchange milliliters to liters. That's going to be one exchange. And then also hours to minutes. So I'm going to do the hours to minutes first. So to get rid of hours, I have to use my 60 minutes in 1 hour. But to get rid of hours, I have to do my hours on top. So 1 hour is the same as 60 minutes. And that eliminates my hours. I have minutes, so that's done. Now I have to do something from milliliters to liters. Now we also learned that there's 1,000 milliliters in 1 liter. That's a true exchange as well. And I put my milliliters on bottom so that I would have milliliters cancel with milliliters, and I'm left with liters. So now that I have circled, I've exchanged my milliliters for liters and my hours for minutes. I can then just multiply my numbers straight across. And I always like to do my units first, because then I know that that's taken care of and I can go ahead and go from there. So I multiply straight across and we get 90 times 1 times 1 over 1 times 60 times 1,000. So that comes up to be 60,000. And when I divide 90 divided by 60,000, we get 0.015 liters per minute. And to write this in scientific notation, we're going to move our decimal so that I have a 1, a single digit to the left, so that would be a 1.5. And every time you move your decimal, remember in the metric system, that's the same. Every time you move your decimal place, it's a power or a multiple multiplying by 10. So I'm multiplying by 10 1 time, 2 times, 3 times to get my decimal right here. So I'm multiplying by 3, and my 0.0015 now looks bigger, 1.5. So that means I have to make this 3 a -3 for that to be equivalent. Okay, so let's turn our page here. So next up is going to be question number 5. And we are talking about converting temperatures. And converting temperatures says, unlike other unit conversions, temperature conversions are done using a formula. We'll get a quick look at why in a bit. There are 2 common temperature units for everyday use. Here in America, we use Fahrenheit in the English system, and in Europe, they use Celsius in the metric system. And then there's a third unit called kelvins. So it says, while in production, the love potion needs to be kept below 400 kelvins at all times. The thermometer on the most recent batch currently read 200 degrees Fahrenheit. One of the formulas provided will convert the temperature to degrees Celsius. So Fahrenheit is what's going into the formula and Celsius coming out. So this is the one that we're going to use. And so we're going to replace F with the value of 200 degrees Fahrenheit. So 5/9 times 200 minus 32. And I will show you this in Desmos. And so we get parentheses 5/9. And then parentheses 200 minus 32. And we end up with 93.33 degrees. Here. Then it says, use one of the 2 formulas provided to convert that temperature to Kelvin. Explain why you chose that formula. Will the batch of love potion be ruined? So here we have formula 1 and formula 2. Formula 2 is the one that we input Celsius here and we get Kelvin, because Kelvin equals Celsius plus 273.15. So when we add our Celsius, the 93.33 to this 273.15, we get 366.48. And this is less than 400 degrees Kelvin, because up here it said that it had to be below 400 Kelvin at all times. So the potion is safe. That's good to know. Then number 8 says, use the calculator or spreadsheet along with the appropriate formula to complete the table which compares Fahrenheit and Celsius temperatures. So they want us to take this table here and take inputs of Celsius degrees and tell us what they are in Fahrenheit. And we can do an equation for that. So they gave us up here, they gave us 2 formulas. This one, we want to start with Celsius and retrieve Fahrenheit. So we're going to use this formula on the left. Celsius goes in, we multiply by 9/5, and we add 32, and we get Fahrenheit. And that's what we're going to do here in this table. And I'm going to show you how to do that in Desmos. Because we're going to be using Desmos quite a bit in units 2 and 3. So I want you to get familiar. So let's go ahead and go to Desmos. So in Desmos, you're going to hit this plus button right here, and you're going to say table. And then you're going to input all of those numbers for the degrees of Celsius. So we're going to put 0, enter 10, enter 20. And notice it, oops, up here, 10, 20, 10, 20, and then 30. And then it starts to know that you're doing a repeat. But because I kind of messed up, it doesn't know, mine doesn't know that. That's okay. Okay, so then over here where it says Y1, we can actually give it the formula so it knows what to do. So we're going to put in the parentheses 9/5 parentheses, and then we're going to tell it X1 because that's what we called it over here. And we could actually rename X1 to be C. And then over here, we can say C. So it knows that it's going to take the C value and multiply by 9/5. And then we're going to add 32 and hit enter. And it actually gives us the values for the Fahrenheit. And so you're going to want to put those in your table, just like I did here, from Desmos 30 to 50 to 68, and so on. So I'll let you take a minute to do that. Okay. So that's good to get used to using Desmos for tables. Then we're going to flip the page. So question number 9 is our lesson check question. And it says, according to the online dosage guide, for one brand of insulin. So insulin is used for people that are diabetic. So this is a nursing problem. The recommended delivery is 0.2 units of insulin per kilogram of weight each day. How many daily units would be indicated for a 178-pound patient? So we're starting with pounds, you can see here, and we are going to units of some sort. So we had to exchange pounds. 2.2 pounds is 1 kilogram, and so we cancel out our pounds. And then 1 kilogram here is the same as 0.2 units. That's what they told us. That's how they've mixed the medicine. So our kilograms canceled and we're left with units, which is what we wanted, units of insulin. And then we can multiply straight across. So I can show you that in Desmos for just a moment. So in Desmos, we've got 178 divided by 1. And then we've got 1 divided by 2.2. And then we've got 0.2 divided by 1. And we end up with 16.18, or rounded to 16.2 units of insulin for that patient that weighs 178 pounds. Cool thing is in Desmos, you can also click this plus button and just write expression, or actually note, and then you can type whatever you want. So you could say 16.2 kilograms of units, actually, right? That's units, 16.2 units of insulin for a 170-pound patient. Okay. Okay, the last problem is a fun, tricky problem. And you can see I've already got my work here, but it says a dosage of a 1700 milligram of cefadroxil is to be delivered to a patient in an IV drip over 75 minutes. So we want to take 1700 milligrams over 75 minutes. But it says it's supplied in a solution that contains 1 gram of the drug in 20 cubic centimeters of solution. That's how it comes. The pump used to deliver the drug uses units of cc's per hour. And remember, cc's are the cubic centimeters. So we exchanged our minutes to hours immediately, 60 minutes in an hour. So we got that done because we wanted it per hour. But then we needed to exchange milligrams for grams, because the way that the medicine comes is it comes in one gram of the drug is inside of this 20 cubic centimeters of solution. And so that's how we exchanged that. So then we got to our cubic centimeters, which is also worded as cc's, right? It's a cc. We learned that a few problems back, over hours, and we multiplied straight across. So I made each of these a fraction in Desmos. And you can multiply straight across and you get 27.2. And I'm going to show you in Desmos how you can do that. So you get 1700 divided by 75. And then 60 divided by 1. And then 1 hour divided by 1000 milligrams. And then 20 cubic centimeters, oops, divided by 1 gram. And we come up with 27.2. And that, as a note, is 27.2 cc's per 1 hour. And that is all I have for you today. So catch me back for 1.5.